Hello everyone. In this video, we will solve one Math Olympiad problem. The question is, given that A, B, C are integers with A times B times C equals 60 and that complex number omega not equal to 1 satisfies omega cube equal to 1, find the minimum possible value of the modulus of A plus B omega plus C omega square all square. Now, here we have the equation omega cubes equal to 1. So we need to solve this equation first. Generally, the equation omega to the power of n equals 1 is very well known. It is what we usually call a roots of unity, and the solution has been known to be the exponential of 2k pi over n, or it can also be written as cosinus of 2k p over n plus I sine 2k p over n, with k can be between 0 to n minus 1. Now we substitute n equals 3 and then we will get this result. So here k can be 0, 1 or 2. If k is 0, then we will get that omega will be 1, which does not allow from the question. So without loss of generality, we can either choose k equals 1 or 2. So here I choose k equals 1, substitute to the equation for omega, and then after doing quick calculation, we will get that omega will be equal to negative 1/2 plus I times square root of 3 divided by 2. So now we use this omega and substitute it back to the expression in question. So the expression of modulus A plus B omega plus C omega square all square will becomes, after we substitute the omega and do some simplification, the final result will look like this. And remember that ABC are integers with ABC equals to 60. And the factorization of 60 is 2 square times 3 times 5. Now we want to find the minimum of the above expression. So usually if we want to find the minimum, we want the variables to be as close as possible. So we make the variable as close as possible, and by looking at the factorization of 60, we can take A, B, C to be the set of numbers 3, 4, and 5. Because we can see that 3 times 4 times 5 is equal to 60. Now, one thing also to look out here is that the above expression is actually symmetric in A, B, and C. So we can interchange A with B, A with C, or B with C. So any permutation of the solution of ABC, here is 3, 4, and 5, will give the same result. So we can just calculate for one possible permutation, which is here I use A equals 3, B equals 4, and C equals 5. So after substituting to the expression of the question and doing some quick calculation, we get the result of 3. So 3 is the minimum possible value for the expression in question. So that is the solution. Thanks for watching.